Thank you very much for everybody to be here. So I'm Christophe Gaudin, as Alain mentioned. I've got a very strong French accent, as you can hear. So if for any reason you can't understand, don't hesitate to wave at the back, and so I'll speak a bit more slowly, or I'll make an effort here. So let's start by respectfully recognize the Whadjuk elders past and present as the traditional owners of the Nyungar Buja on which we are speaking to you from. We acknowledge the tens of thousands of years of indigenous knowledge, culture, and insight into living sustainably and caring for the natural world that have shaped the land and our ongoing research. Thank you, Peta. So as Annalie mentioned, I'm the director of the Ocean Institute at the University of Western Australia. And so the Ocean Institute is a fairly large research center focused on everything ocean. And so we've got nearly 380 members and across all the ocean disciplines, from maritime law, maritime archaeology, and all the way to ocean engineering, hydrodynamics, marine biology, marine science, and so on. The Institute is 15 years old, but our engagement, in the ocean dates back to the last 50 years. And so through that, we have a very strong engagement with industry and philanthropy. Our focus is very much on large multidisciplinary initiatives, so things that basically takes expertise from various disciplines to solve the most challenging problem, and with three priorities across coastal and ecosystem resilience, ocean-based decarbonization, and nature-positive oceans. And so you may wonder why we have an Ocean Institute in WA. Oh, sorry, Peta. It's because we have actually in WA quite an amazing coastline and ocean space. We've got vast wave and ocean wind resources. We've got obviously biggest metropole in WA with Perth. We've got about 3,700 islands, 10,000 kilometers of coastline. And so what's very peculiar and particular about our coastline is that it goes all the way from tropical water in the north to Arctic and polar waters to the south. We've got the Perth Canyon, which goes to a depth up to 6,000 meters. And we've got the largest, coral reef here and the largest seagrass meadows in the world in Shark Bay, and also very extensive and expansive kelp forest in the Great Southern Coast. So it's a very, very unique marine ecosystem in WA, which we are very fortunate to have. And so that's why there is this expertise in research in the ocean across the state and across all the universities in WA that work specifically, on our ocean systems. Thanks, Peter. Next one. Yeah. All right, so I was asked to talk about a bit myself, so as you guessed, I was born in France. I'm an offshore geotechnical engineer, which is very specific, but through my journey, I broadened my expertise and my interest into many various things, including offshore renewable energy. As an engineer, I build stuff, and so I started my career here in 2003 by building what you see here on the left, which is called a geotechnical centrifuge. And I built the National Geotechnical Centrifuge Facility, and that geotechnical centrifuge has been used at the time between 2008 and 2016 to design all the offshore pipelines on the Northwest Shelf, and quite a few in the Gulf of Mexico and in West Africa. So again, we've got here in Perth an expertise which is world leading in many of the offshore engineering aspects. So from 2017, I started to have a strong interest in ocean renewable energy. As I mentioned here, I was appointed director of the Ocean Institute in 2022. And I've been leading the Albany M4 wave energy project that you see on the right, within which we actually design, manufacture locally, deploy, operated, and decommissioned a wave energy converter prototype. And so we did that in collaboration with the local industry and including the local aquaculture industry to demonstrate the potential of wave energy to decarbonize the local economy. And so within that, I represent Australia within the International Energy Agency Ocean Energy System Committee. And so I've got an oversight of all wave energy research and development worldwide. And that has been a very strong interest of mine. Thank you, Peter. Next one. All right, so I may start, to give you a bit of background, about the need for decarbonization, which I'm sure you have heard and so on. But I thought I would bring some details into that here. So every year, the World Meteorological Organization put a state of the global climate. We know that last year, the concentration of CO2 or carbon dioxide gas in the atmosphere has reached 323 parts per million. This is the highest it has been in the last 800,000 years. Why do I say 800,000 years? Because it's basically the time, Homo sapiens, which is us, has been living on that planet. The consequence of that, and so we know that it's basically human-induced. We know that since 1876, actually, and the discovery of greenhouse gas effect from a Swedish chemist Nobel Prize. Carbon dioxide is a very stable gas. It doesn't interact with anything. So when it is in the atmosphere, it stays here, and it creates this greenhouse effect, which basically capture heat and maintain heat on the planet. Through that, we know that there is very important climate consequences that are listed here as a whole. Again, this is the state of the global climate 2024. Last year, the temperature increase compared to the pre-industrial era has been 1.55 degrees, the first time over the 1.5 degree. And so it has resulted in many different consequences, being, significant melting of ice and glacier, sea level rise, and essentially as well, an increase in the occurrence and severity of extreme climate events, whether this is flood, whether this is bushfire, whether this is heat wave, whether this is marine heat wave, which is a very significant issue in Australia. You must have heard that we had our first marine heat wave in the Ningaloo Reef, and that killed about 80% of the coral, in surface, over a few weeks. So all of that, is very well known since the 1970s, and actions have been taken, since 1992, and what was the first, what we call conference of parties between all countries coming under the United Nations to develop mitigation plan to climate change. This mitigation plan requires us to transition from fossil fuel energy to what we call renewable energy. And today in Australia, 40% of renewable energy generation comes from renewable energy. It's rooftop solar, wind, hydro, and grid solar. And so the plan is to increase that by 82% by 2030 and by 100% by 2050 to reach net zero at that time. Next slide, Peta, thank you. And so this is a trajectory which basically is been predicted for Australia. And so you see here the increase from now on until 2050 of the various energy sources. This is a very significant one. There is a very significant effort to be made. We need a 4 to 6 increase, in grid and rooftop solar, a 6 times increase in wind capacity, and that's going to include offshore wind that we'll be discussing today, and a 16th increase in storage energy. Storage is needed to manage the intermittency of renewable energy resources. At night we don't have solar, and so therefore we need to tap into battery to maintain electricity continuity. Next one. So this is the trajectory for Australia. There is a debate into that, whether this is going to be enough. Recently, about 2 years ago, the International Energy Agency actually released a report that details at the worldwide scale, the map to net zero by 2050 in order to keep temperature increase below the 1.5 degrees increase. And the conclusion of that story was essentially 75% of the technology which is needed is not commercially mature yet, and almost 35% of it is still in a very prototype and demonstration stage. So there is a risk that solar plus wind plus battery won't be enough to reach net zero. And so there will be a need for additional technology into the mix. And that may include wave energy, the thing basically that we are working on at the moment. Next one. But let's talk about wind, you know, and offshore wind in particular. So wind energy is actually a very mature technology. The first project, the first wind turbine established date from the 1970s. Today, the technology has converged to a three-blade system. It was not always the case. In the early days, there was different system, you know, 2 blades, multiple blades. This one, the one that we are familiar with, is called an horizontal wind turbine because the axis of the turbine is horizontal. But in the past, we had also vertical wind turbine technology that you may see still here and there. But it's now, again, a very mature technology and commercially established. You've got here a formula that gives you the power as a function of the area of the blades, the density of the fluid, air, and the velocity of the wind. And you can see that the power varies with the cube of the velocity. It is an important factor to consider because this is one of the rationale into moving offshore wind, to moving wind turbines from onshore to onshore. It's one of many parameters, but typically wind velocity onshore is in the order of 4 to 6 meters per second, while in offshore, velocity can reach up to 12 meters per second. And so what the formula says here is that if you increase the velocity by a factor of 2, you increase the power generated by 8. So there is very significant advantages in taking the wind turbines offshore. It's been established, you know, for quite a while, and as a result, it's a very competitive energy. And so here you've got the history of offshore wind farm. I mentioned the very first wind turbine offshore dates on the 1970s, but onshore it's 1991 with a 0.4 megawatt turbine. And over the years, the technology has improved significantly. And nowadays, we've got these wind turbines that are absolutely massive. And so in 2025, the biggest installed wind turbine has a 15 megawatt capacity and a radius of the blades, which is nearly 280 meters. And so there is currently a prototype being developed to reach the 21.5 megawatt capacity. It's currently tested in Denmark. The full installed capacity worldwide at the moment is about 85 gigawatts. And again, worldwide, the expectation is to have over 300 gigawatts by 2035 on our trajectory to net zero. Next one. In doing so, there is a lot of scientific challenges, many, you know, these things are not easy like any big industrial project in the ocean. So we've got a lot of environmental challenges. We need to understand the environmental impact on birds, on their migration path and on their foraging, on mammal as well, and specifically on whales in the WA coast, on fish, and specifically the stock, the impact on threatening species and so on the benthic habitat, lobsters and all the critters that lives on the seabed, and again about the stock, the potential creation, appeal to invasive species, you know, in case you disturb the environment, and things that are coming to awareness these days much more than it used to be in the past. It's actually the cumulative impact of various usage of the ocean combined together, which typically we didn't do in the past. We just look at impact individually, but now we are actually adding that to understand what the cumulative impact could be, and that's a very important aspect of research. There are still engineering challenges, although the turbines technology is very mature. Specifically in Australia, we've got foundation challenges because the seabed in Australia is very calcareous and cemented in nature, and it's very challenging to install foundation in these conditions. We still have manufacturing challenges, not so much in terms of technology, but in terms of understanding, you know, whether we want to manufacture turbine in Australia to boost the economy, create jobs and so on, or whether we will have to import that, which is going to be a different economic model. And we've got transmission challenges. You know, it's one thing to actually generate ocean electricity in the ocean, but we'll have to have transmission lines that bring that to the grid and where it is needed. There is also a lot of societal challenges that Peta will discuss in more details. One being marine spatial planning, so it's the co-usage between different users on the ocean. So where we've got wind farms, we may have as well marine parks that are protected. We may have fishing industry present. We may have recreational activities, like surfing and so on. So all of that needs to be understood very carefully. There's also the challenge of understanding the underwater cultural heritage that may be here, and engagement with First Nation to understand the values, of the space that wind turbines may potentially occupy, and also the social licensing. And there are economical challenges which I'll briefly, but I think something which I think is very important to understand, and it is, in my opinion, is very poorly understood in Australia, is the concept of trade-off. Every project has some level of impact, and so there is a lot of research which is needed to minimize this impact as much as possible. But there is also the bigger picture at play, which is to understand that actually the very first and the biggest threat to bird, mammals, and fish stock and so on, it's actually climate change. And this is the one that needs to be addressed first and foremost. And last one, Peta. And then the last one is about the cost of energy, and the affordability. So as you can see here, you've got the evolution of cost of solar PV, onshore wind, and offshore wind, over the next 3 decades. And like every other technology, costs and electricity price at the end of the line decrease, with not only the development of the technologies, but also an economy of scale. So it's much cheaper to build actually 100 wind turbines than to build only one, and so on and so on. And so while offshore wind energy is still relatively expensive at the moment, and actually more expensive than its onshore wind counterpart and solar PV, it is expected to reduce very significantly and to reach a cost, in the best case scenario, that will be similar to other renewable energy resources. Keeping in mind that the cost of electricity, it's actually a very complex calculation. It's market demand. It's based on market demand, and so the price is actually fluctuating on an hourly basis. And so if you go to the AMWI website, you can see actually the cost of electricity as it changes depending on demand and offer. And that's all for me. So I hope this was insightful, and I'll be very happy to answer questions at the end of the presentation. And so, Peta, I can hand it over to you. Thanks.
Thank you, Christophe. Sorry, I wonder if I messed up the screen at once. I don't know if that was just mine or the others. Sorry, Christophe. I guess too, just reflecting on what Christophe has said, I think for you as students, year 11, year 12, what I would say is if you have any interest in energy at all, whether it's through science, through technology, through economics, or policy and regulation, you will have a job for life, because it is so contentious, it's so political, and it shouldn't be, but it is. And so, it's a pretty exciting field to work in, because I think, the changes that we're seeing is sort of quite significant, and we haven't seen such a technological change for such a long time. So it's just a little shout out that it's definitely a good career to be involved in, but you can choose it from all those different angles as well. So I'm fortunate to be the director of the Institute for Energy Transition. That's at Curtin University, and was only established a couple of years ago, but I spent the last 30 years in Queensland working at University of Queensland, CSIRO, and also living overseas. So I've been involved in energy for a long time. And what we're trying to do, as Christophe talked about the trade-offs that happen, what we see in the energy field, it is very political, it is very ideological. So as a university, and we collaborate a lot with Christophe and other parts of universities in WA and internationally, to try and sort of bring the latest science to help inform government, communities and so forth around, what does this transition mean, and what are those trade-offs, and then how do we find the way forward? And then, of course, we have other researchers working more on the technologies and tools. And for example, a month ago, I was fortunate to interview Professor Shen Rongji, who was the man that invented the solar panel. And if you think about the revolution that has done, he's 62 now, he was 35 when it started, and how that's changed the world. And even now at 62, he is continuing to innovate. So what Christophe's doing with WAVE and so forth, we don't actually know what the next technology will be that will help to unlock this, but we need to, and I think that's the value that science brings to this as we move it forward. So what about me? So I've got a bit of an eclectic background, I suppose, but this is me actually just, the silly screen thing keeps moving around. I was at the World Hydrogen Conference in Rotterdam and went out to visit Yara, which is a fertilizer company. We have some here in the Pilbara, but they are responsible for producing pretty much all of the fertilizer for the world, so feeding the world, so to speak. But at the same time, they produce a large amount of CO2. And so they're trying to work out how do they do that? How do they mitigate their emissions, but still maintain it? You can see in the background, there's solar panels, there's wind, they're capturing CO2, they're sort of doing all of those things. So I'm originally from Narrogin. Some of you might know it, just down the road, 120 miles it used to be when we talked about, probably 150 kilometres. And as I said, before I got into research, I actually used to work, I was a teacher to start with and then worked in retail. So I worked for the Body Shop, which is skin and hair care, so both in Queensland, over in Denmark and in Ireland. And when I think about my career, and then I came back to Australia and got into research, all of it points to this thing of growing up on a farm where water was scarce, working for Body Shop, which was all about human values and sustainability, and then sort of bringing that to research. So it's quite an interesting mix, I suppose. And I was very fortunate to work at University of Queensland, and also at CSIRO developed a group called Science into Society. So I really am interested in that sort of trade-off conversation that Christophe talked about. So how can we integrate science and tech in society? What happens a lot is that it becomes contentious because people ideologies or people get concerned about their lifestyle and livelihood, or they take sort of misinformation and root that out. So I guess that's the role that I'm trying to play, or that a lot of my research does. And then Eleanor, who helped me put this in, I actually completed the Rottnest Channel swim twice this year, which was the first time I've done that. So I love the ocean. And one of those was a solo. So I encourage you all to keep fit as you move forward too. So Christophe's already explained about, the scale of the energy transition, but Australia still has a long way to go. And I think that's part of the challenge. How do we move away from fossil fuels? But what we're seeing is we do actually have the highest penetration of rooftop solar PV in the world. So Australians as individual households are moving that way. You might have heard the WA government and the federal government have a rebate for batteries at the moment, and that's trying to help even sort of secure up when the sun's not shining. But we're still, as Christophe's graph showed and these here, we're still a long way from getting to that sort of 100% renewables or 99%. And whether we will ever get to that is also interesting. How do we sort of smooth out that variability? Often it's batteries. Some talk about the need for gas firming, but that's not in perpetuity. When I was in Rotterdam, the Minister for Energy from Uruguay talked about the fact that they have 99% renewable energy. And he said they took energy out of politics 2 decades ago, and then people trusted them to make the right decisions. And so I think as researchers, we often argue that energy is far too important to be political, as you would see in Australia, and that we need to sort of find an independent way of moving that agenda forward. So one of the things that sort of loomed is offshore wind. And, as you can see here, this quote from our Minister for Climate Change and Energy, we have some of the best wind resources in the world. And I think the other thing, as Christophe pointed out, it's a much stronger, wind is much stronger offshore, but also the beauty of it is that it often is blowing at times when perhaps we don't have as much solar or onshore. So it helps to balance out that renewable energy. However, it is still expensive, especially if it's in deep waters and is it floating and all of these sorts of things that they're trying to move forward. But many countries have installed offshore wind, and it's working very well as part of that whole move to renewable energy. So I'm not sure if you followed any of the debate in your classes, but the federal government approved 6 potential offshore sites, and you can see them here on the map, and one in WA. That was the last one. And it certainly wasn't without contention, was it, Christophe? If we think about, and Christophe and I were both doing some engagement around this at one stage. So there's a lot of projects under sort of consideration at the moment, and off the Gippsland coast down in Victoria, down on the bottom right-hand side, is probably the one that's closest to being operational. But I would say we've probably got a long way to go, and most of the reason for that, or a lot of the reasons for that, is to do with people. And so this is the point where, so I guess people like myself are really interested in how do we actually broker a conversation about this to answer people's concerns. So there's a whole lot of requirements, I guess, by government to engage the public in this topic. But I think it actually needs sort of quite specialists in the ways that you sort of bring people together to have those conversations. So what we're seeing is governments understand this and actually are sort of asking that within the development process that, you know, there is some formal engagement. Christophe's already talked about some of the trade-offs. We know there's groups of fishers that are really quite opposed because they're concerned about what will happen. But when you look at the science, say, for example, I know there's been stuff in Scotland that shows that the dolphins stop sounding when the wind farms are being built, but after they're back again, they come back and start, you know, so it doesn't really impact the overall. And we know that the actual structures in the ocean can be great places for fish to spawn and do all those sorts of things. So there's positives and negatives. And as Christophe said, we've got to look at those trade-offs. And also tourism, some people would be concerned that it's actually a negative, but what we find is a lot of people really love to come and look at the wind farms and listen to them and so forth. So these are just some of the issues that we're sort of starting to have conversations and dealing with. But it's also to say that these same sorts of considerations, obviously not the ocean type ones, also occur on land. Like no technology seems to be deployed without some sort of opposition. And here's some more. And I think, you know, what I wanted to show in this picture is it's not just Australia, it's around the world that we have these protests. And so I do a lot of work with my group when we think about social license to operate. And when you look at these pictures, you would say that they don't actually have a social license to operate right now for these projects. And you can see because people are protesting, often there's blockades or there's complaints from neighbours, those sorts of things. But what we know, when I was at CSIRO, some of my colleagues who were psychologists looking at this topic sort of came to sort of really understand and unpick what's the social license to operate. So what we know is that it takes time. So it's a bit like you developing relationships. You need to build trust. So you've got to have lots of opportunities for people to engage and to ask questions in a safe space. And the other thing is that even if you start to develop a social license, it only takes one thing to upset the apple cart and then we can sort of go back to square one. So I think these are the considerations that we think about. And from a science perspective, because often social science is sort of seen as, you know, the soft science and so forth, but there's actually quite a lot of rigor. And so from the point of view of if you're interested in careers and so forth, there's a lot of work that's done by environmental psychologists, social psychologists, and we work very closely with the technical and also industry to try and understand exactly what is it that people are protesting or what are their concerns. And this is just one example of a model that actually you can design surveys to really start to understand what it is that people are responding to. So for example, I won't go through all of this, but on the outside, we all come to these situations with our own experience and knowledge, and that's often shaped by the values of our parents and our friends. But then also, obviously, trust is critical. And down in the green on the bottom, we talk about procedural fairness and distributive fairness. And that's what we talk about with process. How do we engage? How do we bring people to the table? But also distributive fairness is around this idea of what are the benefits to the local communities for hosting such projects. And so that could also be the fishers' concerns about, will they lose their livelihood and lifestyle? So there's different ways of compensating, and it's not always about money. It's not always about jobs. So there's a lot of things that we need to unpick. And what in that middle row, it looks like the blue at the top is sort of that the words were positive or negative effect. That's really how you feel about a project. Do you feel more positive feelings about it or negative? Because that will influence. But also you're trading off the costs. You know, as Christophe talked about affordability, a lot of people are struggling with cost of living, and do they see just cost of electricity going up and adding to it? Is it all about the transition? But we know with renewable energy, it will get cheaper over time. And so therefore it's worth staying the distance. But also, do they see risk and benefit? How do they trade those off? So all of these things come together. And then that next part is all around, what do my friends and family think? Where do I fit in? So even within your school buddies, you would be forming opinions about these technologies, you know, and probably in your classes having conversations. And so those trade-offs and different ideologies is what will eventually lead to acceptance. So I really just wanted to put that up because at where you're at in your school and career and thinking about these next steps, there are many different ways to engage in this topic. And all of this is science from different angles. So I guess if you're not into engineering, there are other opportunities to really move this forward, not to mention policy and so forth. So I think that's really all I wanted to say.